We would like to welcome our speaker, Balasundaram and Ajithkumar Lakshmanan. Balasundaram is Associate Director at Cognizant Technology, and Ajithkumar is a Senior Associate at Cognizant Technology. Balasundaram and Ajithkumar would be delivering an interactive talk session on From Bottlenecks to Breakthroughs, Transforming DevOps Testing with Generative AI. To know more about Balasundaram and Ajithkumar, please check the given links. And handing over to you both. Okay, thank you so much.
Are you able to hear me?
You can share this one. Yes.
Yes, Bala, we can hear you.
Yeah.
Are you able to see my screen?
Yes.
Okay. Good afternoon, everyone. I'm Balasundaram from Cognizant Technology Solution. It's a pleasure to be here with you all. And I have
your audio is not clear, Bala.
How is now?
Maybe you're away from. Yeah, this is better. Thank you.
Okay. Thank you. Okay. Good afternoon, everyone. I'm Balasundaram from Cognizant Technology Solutions. It's a pleasure to be here with you all of you. And I have more than 20 plus years of experience in IT industry and playing a senior architect role, managing test automation using GenAI, cloud, and continuous integration. Joining with me for this session is my colleague and co-partner Ajithkumar. And the focus of our session is transforming DevOps testing with GenAI. GenAI is across everywhere. Now we are going to see how to adapt GenAI with our DevOps process. Here we explore the key challenges faced in DevOps cycle and discuss how generative AI can be leveraged to address the challenges effectively. With this context set, let's move to the agenda of this session. Okay, the agenda of the session is, first we will start with explore the real pain points the team is facing in CI pipeline. Next, in the conventional AI approach, why it's hard to solve the CI pipeline issues. That's the second topic. And third one, we explore how GenAI can be strengthened and streamline the CI pipeline process. Next, how we can seamlessly integrate the GenAI process into the DevOps. And we will see in different stages, we will have in each stage how the GenAI can be adapted. And finally, the benefits and takeaway. So here we see some of the common challenge in the DevOps pipeline cycle. The first challenge is unstable environment. The build process is one of the key activity in pipeline process. In many situations, build code failed due to the dependencies not properly updated or library files are not properly bundled together. That is the main challenge. And the next challenge is the misconfiguration of the configuration files. So these are the challenges we have with respect to building the application in the test environment. The next challenge is the feedback loop. The first challenge of the feedback loop is unstable environment. For some of the common scenarios are the build phase due to the long, huge size of the code base got built together and it takes long time. And in testing phase, the test execution is happening in a sequential order. Because of it also, the feedback loop got extended. That is another challenge we have in DevOps in the traditional approach. And next we have the poor test optimization. What here we will have? We have the test cases to be optimized effectively. For example, for a small change in the feature in the application, the build is going to be developed. For that build, we are going to execute all the test cases. Instead of that, we need to see what is the impact-based test cases need to be identified. That is not happening in most of the projects. That also one of the reasons for long feedback loop and challenges we have. Next challenge here is manual debugging. If any fail, we have many phases like building, testing, and deployment and monitoring. In all the phases, When there is any failure comes, it requires manual intervention to understand the failure. Because of that manual intervention requires the feedback loop also, it takes long time. So these are some of the points we need to see where we can integrate our GenAI concepts into the pipeline process. And finally, the predictive analysis is not there across the cycle of the DevOps pipeline cycle. Next, we see what are the traditional pipeline struggles we have. Okay, the first reason is manual intervention. As mentioned, there are different jobs will be run in the life cycle, in the DevOps life cycle, where we need to modify the configuration files. When there is any build failure happens, when any job gets failed in the CI pipeline, automatically we need to see the error in the error log or the configuration logs we will see. During that time, we need to do it in a manual intervention is required. And next point here is inconsistency in the environment. For example, we have a different stages. We have stage, we have production environment, stage environment, integration environments will be there. In each environment, we need to deploy our application. The build and automation scripts get paused and deployed successfully in stage environment, but it won't happen in the production environment or integration environment. Because of this issue, the inconsistency of environment happens. That is also one of the reasons for the pipeline failures we have. And next we have the repeated test failures we have. For example, the scripts will be passed in one environment and it got failed in another environment, and there is no technique we have to auto heal the application, to auto heal the failure and fix it in a runtime, because that is also one of the struggles we have in a CI pipeline. And the next one is reactive approach. In the reactive approach, we know the reason for failure at the end, not at the earlier stage, not in the predictive manner. So we need to have a predictive mechanism. We need to have a reactive approach is required in the CI pipeline to have a successful end-to-end execution we have. So for these critical challenges we have discussed, we have looking for a solution where we can integrate GenAI into our DevOps pipeline. For example, if any log failures happen, we need to bring the GenAI model into the pipeline to analyze the data, to validate the past failed build failures. It analyzes the past log, failure log, and it will keep it and make the build got success. There we have an opportunity to bring the GenAI concepts. Next, we have analyzed the logs. So we need to understand the root cause of the failure in a runtime in the cycle, and we need to find the solution using the GenAI concepts. And finally, we have identifying the auto healing also we have. We need to enable the auto heal. We need to bring the pipeline need to be executed without any break. Next, Ajit will share the concept on GenAI architecture. Yeah, Ajit.
Yeah, thanks, Bala. Thanks, I can take over from here. So let's just walk through this left to right and the way to run the real project. And you are seeing the left side is in a dev workstation, and middle is in a Azure DevOps, and third zone is in a generative AI brain. So start from the left side, the developer workspace. This is where everything start. Developer work in the VS Code and GitHub Copilot with the help of the code faster and even draft the test. And here we develop the tech stack in the React, Node.js, and MongoDB, and Playwright. Playwright, everything developed in the workspace. Once the work is ready, and commit to the Git and push into the GitHub repository. So we return that raise that any PRs in validating through that GitHub Copilot. Then Azure automatically move to that Azure DevOps pipeline. That movement code is pushed to that Azure DevOps CI/CD pipeline and kick off that CI/CD. It's follow usual flow. First is go to the build. It's a regular way to build the Docker build and move to the Azure registry container. Then move to the next stage of a test. And once it will use the consistent uh, Docker images throughout the production process. So it will test that playwright, and once this test case is passed, and move to the deployment state and run it in the Kubernetes cluster. Then move to the final stage of monitoring, where that our production code is run, and up to here, the normal traditional DevOps setup is going on. Came to the right side of an GenAI intelligence layer. Now you see here in the right side of an that movement, that code is pushed to the Azure DevOps, and now the smart part is came here. So this is the pipeline connect to the Azure OpenAI, which is act like an GenAI engine. So between them, we have an MCP. So it's like an adapter, the connected layer. The think of this where the bridge and the send the GenAI the right context, like in a build logs, test results, deployment info, alerts, trace, and past pipeline histories. And the GenAI brain, what does give you back? And that once the GenAI get the context, like help the pipeline the few powerful way. And I mentioned here the self-healing, and that way the failure can then environment and based, and the suggestion fix when the build or a test fail happen, it will suggest the fix. And infra suggestion, if you detect that any misconfiguration, it will take that action. And the fourth one is in a risk detection. Before you run, everything is detecting the risk. So give the indication and auto generation test case, and based on that code changes, it will give this auto generate cases. And finally is in a root cause analysis. So the team don't waste the time to digging the debugging or hours of time to what is the issues going on. It will give you root cause analysis. So through the all the loops and that all those inside that flow into the build, test, deployment, monitoring. So the each run learn from the previous one, and that pipeline keep that improving over the time. So this is the architecture of this diagram. So we are not replacing the traditional pipeline. We are just adding the GenAI intelligence loop around them that we should predict easily, fix, and came faster, and manual firefighting drops and lot. So, all right, let's now that this architecture is clear now, then let's break down the stage by stage of seeing what GenAI is in each part. Move to the next slide. So here we are going to see that build and testing the stage. Okay, and here the how is build start. Before the build start, it detect that unstable configuration. The GenAI check that PR, the changes. The pipelines YAML Docker files update the dependency dumps and environment variable. If it finds something has been broken, build before it flag it. And early, we don't waste the time. So it will help take that action. And second is during the build, analyzing the historical build logs while the build runs, GenAI read the live logs and compare them, which is past build pattern. If your today's warning look like the early failure, it will predict the risk step early. So third is during that build, suggestion the fix of recursing the issue when that GenAI spotted the repeated failures. So that failure pattern will be repeated. It will immediately recommend that fix them work here. So the team don't know that keep solving them the same build the problem again and again, and it's doing in the third phase. And fourth, after that build, auto-generated build script. If that once the build is ended, and the GenAI check that if that pipeline still match with that code, the if the new services or step is missing, is process updating the YAML script and the Docker updating the Docker steps and for the next run. So it will prepare. So it's a, what is an outcome here? It's an improving the build quality. And because of this build, because of a more stable and faster and less flaky test, and the green build now actually means that artifact is ready, move to the next step forward to the testing phase. So in the right side, you're seeing that making the test phase smarter and raising awareness here. Before the test started, either prioritize the test cases. GenAI, how the prioritize the test cases is the GenAI read that code and different and the risk history, the select the most important written in the playwright test first. So we test what's the matter, the most important run. Instead of running in every script, it will run that important script only. It's not running everything blindly. So it's prioritizes the test cases during the test execution time, and that it auto generates a test. So if the GenAI notice few flows without coverages in the draft, the playwright script, the team review accept them, and the coverage growth within every changes. So in the development phase, we are doing like this. And during the test, the detect that flaky test, the GenAI watch retry the history and interrupt that failure. The test keep that failing on and off. So it's marked as a fail and suggest the stabilized step next run onwards. After the test is finished, to perform the root cause analysis, RCE means root cause analysis. The GenAI read the playwright logs and screenshot and trace and videos. It summarizes like in a root cause analysis and point to where we should look at first. So it will do that first. And final outcome is in reducing the manual effect. So in this phase, reducing the manual effect. So playwright keep running the test normally, but the GenAI handle the prioritized test draft, and so the team can spend debugging or improving the more quality build stable and more faster. So the testing become the smarter and more easier to maintain. So this is happening behind the scenes. So now it's how the stage is shifted from the biggest bottleneck to the real breakthrough. So now we see the build and test. Let's move forward to the pipeline. Look at that how the GenAI improve the deployment and monitoring the stage where the recoveries matter the most. And we are going to see that next deployment phase. So move to the next slide. So here we are seeing that analyzing the pre-deployment, and so this slide is showing on the how the GenAI looks after the deployment and how it's behaved. And I will explain this simple day-by-day activities, how we can do that one. And before everything goes to the production, the GenAI looks at early signals like an build health and playwright test is passed or not, and performance balancing, the recent error rates, infrastructure, how it's look like, what happened in the similar past release. So we spotted the risk before we deployed to run. So these are all that happen after the in the deployment, pre-deployment. Okay. So in the second, the recommend rollout window. The rollout window is in a main. Next 2 point is in a main thing, and many of the deployments because of fail, not because of bad time, not just a bad code. So the GenAI learn which is time window that usually safe for your system on the traffic, that pattern past history, then recommend the best rollout windows to given on the upcoming releases. So in the third, the suggestion deployment strategies. So how we can do the in the GenAI means that once the GenAI understand that changes and impacted the risk level, and recommend to the rollout styles, like could be the green or the gray. It could be that a pattern we can follow that one way, and so the strategies match the risk instead of using that one fixed and every time. So automatic rollback logic is very important in case the production the build is going to that with an error, and we return that uh, own logic to revoke it back and apply the previous build back it again in the production. So it's happening in that GenAI actions. Okay, and it's in a final outcome is an improving the deployment confidence here. Because of the risk is predicted easily, the time is safer, and strategy is smarter, and the rollback is in a protected. The team deployment is much higher confident, even complex multi-service steps. So these are all in happening in the development phase, deployment phase, and those five together, GenAI turns the deployment from the risk final step into the safe and intelligent stage. So these are all happening in the deployment. So now the deployment is covered. Let's look at that monitoring, that how the GenAI help after the release to the detecting issue earlier and recover more faster. So and came to the GenAI monitoring, continuously analyzing the metrics, the logs, and trace from the Azure monitoring and Grafana, and it will closely watching the live production environment behavior. And so its monitoring does not depend only on the human success checking, since it's running continuously watching. The second is an anonymously detecting detection, that while watching the stream and the GenAI looks the behavior and feeling that abnormal, think like an CPU high, like in a memory latency or a sudden error burst and the traffic shifted. The key point, the caption the issue early, so before they become the full outages. And it's come to the third and the corrective action that GenAI spotted anonymously, that does not just suggest that most like to fix based on the past incident. It could be the scaling the services and restarting the parts and rollback and stuck the isolation the dependency, so the team can clearly guidance right away. So the fourth is an main pointed out that the self-healing that workflow. How the self-healing workflow here, that the common and repeatable problems, and the GenAI can trigger the recovery automatically using the runbook, like the same pattern repeated again again again. It means the system healing itself. Threshold crossed without wasting time for the human to jump into the firefighting. So it will perform in the self-healing action. So fifth is a CI/CD feedback. It's in a, once that feedback is in a we need that feedback continuously. Every GenAI learned from the production flow back into the pipeline. What failed, what signals won early, and what fixed work, and what test is missed. And so the next CI/CD run becomes smarter, and same issue is less like to repeat. So these are all the five inputs. Those five inputs turn into the fix fast and learn continuously. Now that we see in the GenAI across the build and test, deploy and monitor, let's wrap up with an central GenAI based and final slide of an key benefits and takeaway. So here is an the central brain. So far, we saw about the different phases. This is that happening behind the scenes. This slide, the think like an one intelligent layer and set across the whole DevOps pipeline. And first, the learn from the all past pipelines. Every build failures, like in a failure play rate test or slow deployment or rollback or production issues, become the memory. And so each run the start the new smarter and not from the scratch. It's not behave like an treat like an you're running in the first time. So it will adapt it in the second and integrate that directly into the DevOps tool. It's connecting the open Azure OpenAI and then native Azure MCP servers, and that already the team uses it, not that external added one. And the third is in a support the developers inside that ID, that while that coding that in the development phase and writing the playwright script or in the Visual Studio Code, it give you a contextual suggestion, give the better assessment, better selectors, and better coding standards given, and the risk dependency awareness and or the pipeline fix. That's all prevention. Start early. At the desk development desk. And fourth is an feed on observability signals in the production logs and metrics and into the MCP brain. So the GenAI can learn from really what happened after the release and improving the next predictions. So that final, it's all connect to that end-to-end flow. After the collecting the artifacts and infrastructure as a code and running a Kubernetes pods, and this is all monitoring the dashboard. So when it flags writes or suggestion fix, it use the full pipelines and production in context to came right into the GenAI picture. So this is simple. Give it overall 5 points. Those 5 points together, the brain of the system learn one learn loop across the build, test, deploy, and monitor. And every run make the next one safer and faster and smarter. So we covered the full flow of a central brain and clear the close into the real benefits and takeaway the team get from this. And we can move to the next slide. We can see that key benefits and key takeaway. So that we are in a final slide. This is about the benefits and key takeaway. This where the phase from bottleneck to breakthrough, the real make the sense. So first we are going to see the intelligence that GenAI bring the learning and reasoning into the every stages and build playwright test running in that end-to-end user journey in deployment phase and monitor phase. And so the pipeline is not just a setup anymore. So the pipeline is not it's become the intelligence loop improving after every run. The second benefits is reducing the effort. So today we spend a lot of time for failure build and failure test cases and manual finding the root causes. So GenAI reduce the load and predicting the issue earlier, summarize that failure and suggesting that fix and enabling the self-healing and less firefighting and more forward progress. And the team third benefit is a team focus. No need to looking on the firefighting what is happening on hours debugging and what is happening behind the scenes and a lot of video watch the solution video watch. No need to do that. They are focusing on the stronger test design now, better coverage and safer future delivery. The quality become productive and aligned and not a reactive. So reactive approach. The fourth benefit is a faster feedback. So become a GenAI prioritize the right test and predict the risk early, the speed up the root cause analysis and feedback become quicker and cleaner. So this pipeline turn into that faster, uh, reliable, the single instant of a slow the bottleneck. So the final is in a risk management. We are in a final benefits. So the GenAI predict where the risk is bundling before the failure is happening. It's recommended to roll out that window, the strategies and watching the production and the triggers and correctiveness and the rollback action when needed. So the release move from the hope it work to we know it's safe. So these are all the benefits, key benefits. And when you put those points and GenAI does not fix that one problem. It's fix that it fix the transforming the pipeline from reactive manual into the prediction, learning, and self-healing, improving. This is a real shift from the bottleneck to breakthrough. And thanks for the opportunity to present this.
Yeah.
Any questions? I can
Yeah.
take it up.
Yeah, we have one question. Charles, can you unmute and ask your question? I can see that on your chat. And we have another question also. We'll see based on the response.
Yes, hi. Can you hear me?
Yeah.
Yeah, we can hear you.
Yeah, hi. So let's see. I had a second question as well. So yeah, I was wondering how the prioritizing of test cases happens. Is impact analysis of code changes part of it? I would think so.
Yeah, it's can do that. Prioritize the test you are asking. That it's how we can prioritize the test. No, it will once you raise the PR, it will monitorize the previous log and current log. It will give the suggestion, and it will go for an not run it blindly. Run the entire test scripts. It will prioritize the test. Give the suggestion to the PR. So the testing phase, it will execute only that prioritized one.
I see. Okay. And a bigger question would be, well, how is all this implemented? I missed a couple of minutes in the beginning, maybe 5 minutes. Is it
Okay.
something we build? It's an agentic orchestration we build? Are there tools ready to use?
Okay, we used that Azure OpenAI LLM model, and we used that MCP, that Azure DevOps MCP, and these are all we use that in Azure side, and we use that for developing speed purpose. We use that GitHub Copilot.
Okay, so these are existing tools that we just configure. Yeah, perfect. Thank you. Yep.
Thank you, Charles. Okay, we have one more question, and before we go with the next speaker, which starts at 3:25, we'd like to take that question as well. Preeti, can you ask your question? Or it's that answer in the rest part of discussion? Okay, so I guess it's answered in the remaining. So we'll request Ashita, if you can formally thank our speakers, please.
Yes,
For the
yes.
thank you slide.
Just a minute. I think the flaky, Preeti here, the flaky test was not answered. So I have written down the question there. So I was just expecting an answer.
Okay.
Asha, sure, go ahead.
Okay, this how the flaky test is done. That in that we have in 3 phases: post build and pre-build. So once that build is completed, in the inside that we run that unit test cases, or we run that containerized Docker containerized test case mapped to that latest images, right? So that time continuously our LLM model monitoring the test. So it will detect that flaky test, get the report from them, then the next build onwards, it will create the prioritized the flakiness test and give the suggestion. It's auto creating the branches. It will suggest that the test case is inside the script. So this is happening behind this in the flaky test.
Okay, so that is auto triggered.
It's not an auto trigger. We need to first manually check this is a valid script or not. We need to. There is some manual interruption there.
Okay. And about the build pipeline, so those tests which cause any interruption for the build pipeline, those are also corrected? Or there are some alerts which comes?
Each of the phase
Preeti, in the interest of time, we'll have to take the follow-up questions offline. Yeah,
sure.
Thank you, Preeti. You can connect with both the speakers on the LinkedIn or offline on the chat. They can. Thank you. And Ashita, we can have a thank you slide presented. We'll have to stick on the screen. Thank you.
Yeah. Thanks a lot, Balasundaram and Ajithkumar, for your wonderful session.